Hey guys, good evening, all of you. Guys, in the last section we have done with all the BGP states and the masses tab. So let's recap all those things. So we have seen the BGP masses tab, right? So we have gone through that for open masses, right? Then we have gone through that keep a lab. Then after that we have discussed about the notification masses. Whenever any error comes in the BGP, it will generate the notification masses. And after that we have seen the update masses. So in this update message we have an array information. An array is nothing but it's just a network layer utility information that contains the subnet mask information. At the same time, they will contain the prefix information as well, right? And in the update packet also we have a withdrawn routes information, right? At the same time, what happened? We have a BGP attributes information. So BGP attributes is nothing but it's just a extra information. It is extra information about the route, like our next hop, metric, AS path information, right? These are the BGP attributes. Then after that, we have seen in the last classes the BGP states we have, right? So we have gone through the ideal state we have, then we have a connect, and we have a active, and then we have gone through the open center state. We have open confirm, and the last one we have a established state, right? These are the states that we have seen. So this three is the first three state is going to represent a TCP, right? So if you have any TCP related issue, then the router will stuck in this three state. And in this state, what happened? The BGP router is going to exchange the message information. In this open state, open confirm established. In this state, what happened? The router is going to exchange the open message and keep alive message. And if there any error will be there over there, then it will generate the notification message. And if any update is happening, then it will generate the update message. Doesn't matter if the interface goes down or interface will be up. In this case, the router will generate the update message, right? And also we have seen we have a two flavor of the BGP, right? So one we have a IBGP flavor and one we have a eBGP. The IBGP stand for external and whereas IBGP stand for internal. The main difference is that IBGP is going to implement the same AS number, right? Whereas eBGP will be implemented in the different AS number. Okay, and IBGP by default, the TTL value of the IBGP we have a 255, whereas the TTL value of eBGP is by default 1. So these are the flavors that we have seen in the IBGP, and we can form the directly neighborship, right? Directly neighborship in the sense what? Both the router present in same broadcast domain. That's the meaning of directly neighborship, right? At the same time, we have an ability to form the indirect neighborship as well as. Indirect neighborship, what happened? Both the router, we can say that, or the IP addresses, right? Domain. So this direct neighborship will be happening in the IBGP as well as or EBGP as well as. Now, let's start the today topic. Hey guys, if you remember in EHGRP, not EHGRP, first go to the RIP. In the RIP, how we can prevent the loop? If I'm going to talk about the loop prevention mechanism, right? In RIP, we can use the split horizon rule, right? In EHGRP, we can use the split horizon rule. At the same time, we can use the concept of router ID as well as between the two different AS number. We can use the concept of router ID as well as to prevent the loop. At the same time, in OSPF, what happened? We have a area 0. That's a backbone area. And backbone area used to prevent the loop, right? So depend on the routing protocol. If I'm going to for the IGP protocol. So in IGP, we have a RIP, we have a separate mechanisms, a split horizon rule. We have more things in the RIP as well as like a hold on time and voice and reverse as well. So right now I'm not discussing all this thing. I'm just talking about the whatever the loop prevention mechanism we have in the protocol. Like in a RIP, we have a split horizon rule, ESGRP has a split horizon rule, at the same time we have a router ID concept, and OSPF has a area 0. Same thing will happen with the BGP as well as. First of all, in the BGP, what happened? We have a two flavor. First of all, in the BGP, what happened? We have a two flavor. iBGP and eBGP. So in iBGP, what happened? We have a separate mechanism, right, to prevent the loop, and eBGP, we have a separate mechanism to prevent the loop. So itself, BGP has a two flavor. In iBGP, we have a separate mechanism to prevent the loop, and in a eBGP, we have a separate mechanism to prevent the loop, and both are independent to each other. In iBGP, we are going to use the split horizon rule to prevent loop in iBGP, and by default, it's enabled. Whereas in eBGP, what happened? In eBGP, we are going to use the ACE path information to prevent loop. And by default, again, it's enabled. There's someone mic is on. So depend on the route, depend on the flavors, right? Both have a separate mechanism. iBGP is totally, this guy is totally independent to this person. So how this thing will work? First, let's go through the eBGP case, how we are going to prevent the loop in the eBGP. Then I'm coming to the iBGP as well. So for example, we have a router number 1, right? We have a router number 2. I'm talking about the eBGP perspective right now, and we have a router number 3. One minute, let's take a. So we have a router number 1. We have a router number 2. We have a router number 3. Oh, right. So we can make this router number 1, router number 2, router number 3, and router number 4. I'm going to use this interface, right? So I'm going to provide the connectivity via this Ethernet cable. So this guy has this one, this guy has this one, and this guy has this one. Right now, I'm talking about the perspective of the eBGP loop prevention mechanism. ASPAN, right? So what happened? This guy has an interface, this interface 0/0, this interface 0/1, right? This interface 0/0, this interface 0/1, this interface 0/0, this interface 0/1, and this interface 0/0, and this interface 0/1. All good. So this my interface IP address is 12.1, and this my interface IP address is 12.2. Right? I'm going to use the network ID over there 192.168.12.0/24. Right? Same thing. We have a 23.2, and we have a 23.3. And I'm going to use the network ID over there. It's a 192.168.23.0/24. This guy should be 34.3. Sorry, 4. This guy should be 34.3. And this guy will be, I'm going to use the network ID will be 191.168.34.0/24. At the same time, we have this guy will be 14.1, and this guy will be 14.4. I'm going to use the network ID over there 14.0/24. Try to understand this guy is going to run with the ACE number 1 because we are going to make a eBGP connection, because we are discussing right now eBGP loop prevention. So this guy is ACE number 1, this guy is number 2, this guy will be ACE number 3, and this guy will be ACE number 4. So right now we are doing the eBGP loop prevention mechanism by using the ACE path. Now, so what happened, guys? I'm going to run the eBGP connection, right? So it will be a eBGP connection, right? At the same time, it's also a eBGP connection over there between the two different AS number, and it's also a eBGP connection, and it also will be a eBGP connection. So because between the router number one, or we can say the AS number one and AS number two, we have a eBGP. AS number two to AS number three, we have a eBGP different AS number, or AS number four to the AS number three, we have a eBGP, and AS number one to the AS number four, we have a eBGP. Now, R1 has some information. For example, they have a one LAN network over there, or we can say that any network. For example, we have a 1.0.0/8. Okay, 1.0.0/8. In a BGP, we have a four version: BGP version 1, version 2, version 3, and version 4. By default, the version 4 is enabled. Version 2, 1, 2, and 3 we are not going to use because it's a class full. So this version has introduced before the 1993, before 1993. Because itself in the 1993 we have introduced the concept of classless. So all this router is running with the BGP version 4. So if this guy is running with the BGP version 4 and that is a classless, so what happened in the classless routing protocol, we are going to send the subnet mask information in the update packet. So in this update packet, we are going to send the subnet mask information as well, right? In a classless routing protocol. So try to understand, we all have a pre-configuration of the neighborship right now between this guy. So in this case, what happened? Router one will send the update packet to the router number. Router one will send the update packet to the router number two. In this case, in this update packet, what router number one will do? It is going to send this update 1.0.0.0, right? /8. At the same time, what happened? They will send the next hop information as well as this 12.1. At the same time, router one is going to add the own AS path information. So we can say that whenever BGP router will advertise any information, or we can say that whenever BGP router will send any update packet, in that update packet, what happened? It put some extra information. It put some extra information about the route, and that extra information is known as BGP path attributes. So one of the attributes we have one is the next hop information. Right now in front of you we have a next hop information. One of the attribute we have a next hop information right now, and one we have a AS path information. So right now when R1 will send this update 1.0.0.0, it puts some extra information. One extra information is the next hop, that is this guy. At the same time, AS path information, that is my own AS number. When R2 will receive this information, what R2 will do? R2 will maintain this information in the BGP table. He said that, okay, 1.0.0.0.0, next hop 12.1, AS path will be AS path will be 1. After that, what R2 will do? R2 will prepend the own AS number. When R2 will send this update to the R3. When R2 will send the update to the R3. When R2 will send this update to the R3, this update, what happened? This guy is going to prepend own AS number. So in this case, what happened? R2 will send this update to the R3 1.0.0.0/8, because this is the classless routing protocol. We need to put the subnet mask information. Then after that, we are going to put the next hop will be 23.2. This guy. Because R2 is sending the next hop will be 23.2, right? And now after that, this guy is going to send the AS path information will be 2 colon 1, because I need to prepend my own ACE number. So ACE number 2 will be prepend. So when R2 will send this update to the R3, what R3 will do? R3 will accept this update and put this information in the BGP table. He said, okay, 1.0.0 information is coming by the 23.2, and that are AS path information will 2 and 1. So in this case, what happened? R3 will accept this information and R3 will send this information to the R4. Try to understand one thing. I'll do one thing. I'll put this update. Right? Try to understand one thing. When R3 is sending this update to the R4, which update? 1.0.0.0/8, the classless information as submit mask information. Then we have a next hop will be 34.3. Now the R3 is going to put the own next hop information, and the ACE path will be now. It is going to prepare the own ACE number now. So what R3 is going to do, it will put the ACE number 3, 2, and 1. It is going to prepend, right? So when R4 will receive this update, what R4 is going to do, it maintain the BGP table information 1.0.0.0. Next hop will be 34.3, and the ACE path will be now 3 colon 2 colon comma 1. When R4 will receive this update, what R4 will do, it will send this update to whom? R1. And the update now will be look like this: 1.0.0.0/8. Next hop will be 14.4, right? And AS path will be, it is going to prepare the own ACE number now. R4 is also going to prepare the own ACE number. This is the default behavior, right? Every router, every eBGP router, is going to prepare the own ACE number. Every eBGP router. So when R1 is going to send this update to the R4, sorry, when R4 is going to send this update to the R1, how this ACE path information will be there? The ACE path will be now look like this: 4, 3, 2, 1. This information R4 is sending to whom? R1. When R1 will receive this information on this particular interface on a 0/1, what R1 will do in this case? R1 will say that, okay, this is the update packet, and this update packet, what happened? We have a information 1.0.0/8 that I'm getting from the 14.4. That's perfect. Then after that, R4, sorry, this router number 1 is going to look up the ACE path information. The ACE path saying that 4, good, 3, good, 2, and 1. This ACE number 1 that belongs to me as well as. It means that this packet is generated by whom? This update packet is generated by, or we can say the origin by R1 itself. So I'm sending this packet from this interface, but I'm receiving the same packet on this particular interface. In that case, what happened? Loop is there. So what R1 is doing over there, R1, just by looking this information, ACE path information, right? Just by looking the ACE path information, what R1 is going to do, R1 will just discard this packet. R1 will just discard this packet, and this is how we are going to prevent the loop in eBGP by using the ACE path information. Just by looking the ACE path information, we are going to prevent the loop in eBGP. Every single eBGP router is going to prepend the own ACE number. So when R1 is sending this update, can we have a look over there? When R1 is sending this update, we have a ACE path 1 over there, right? When R2 is sending this update to the R3, we have a ACE path 2 and 1. Oh, sorry. So when R2 is sending this update, we have a ACE path 2 and 1. And when R3 is sending this update, we have a ACE path 3, 2, and 1. And when R4 is sending this update, we have a 4, 3, 2, 1. So every router is going to prepend the own ACE number. And when R1 will receive this update, it will look up the ACE path information. In the ACE path information, what happened? They'll find the own ACE number 1, right? Based on that, they will just discard this update packet. Just because of the ACE path information, what this guy will give the message over there, deny update because of own ACE number. This information will be displayed on your router. And this is how we are going to prevent the loop in the eBGP. Let's see this practical, what I can do right now, guys. The same topology we have, right? Start. So I'll show you the first pre-configuration of the every router. So R5, R6, R8, R7, or R6 we have. So we have a 50.8.5 and 58.8. We have a 87.8 and 78.7. At the same time, we have a 67.6 and 67.7, and this interface we have, right? So we have one loop back over there, and they all have a different AS number. AS number 5, AS number 8, according to the router name, AS number 7, or AS number 6. Capture this link. Sorry, not capture. You just console this guy, console of this person. R8, R5, R7, and R6. So I'll first show you the like whatever the pre-configuration we have on a router number 1, on a router number 5 and 8, 7, or 6 router. What are the pre-configuration we have? So all we are forming a direct neighbors relationship right now. So if you go back to the router number 5, first of all, so this router number 5. So if you see show IP interface brief exclude unassign. So we all having IP addressing and stored on section BGP. If you just check the pre-configuration BGP, we do have a normal configuration right now, and we are forming the BGP relationship right now. All we have a BGP neighborship. R5 is complete, right? Let's come back to the router number 6. So we have this guy. Everything's good now. So run section BGP, all good. So IP BGP summary, all we have innovation. At the same time, if you go back to the router number 7, that is this guy. All good. We have a correct IP addressing configured over there, right? And then we have a BGP is fine. Also, we have a good navigation. All perfect. Router number 6, we have, sorry, router number 8, that is this guy. So we need to check the IP addressing over there as well as. All perfect. So run section BGP and so IP BGP summary. Everything is good, right? So now let's do one thing. I'm going to enable some debug on router number 5. Debug IP BGP update. And on our router number 5, I'm going to advertise this router. Network 5.0.0.0.0. And let's see what happens. So when R1, sorry, not R1, R5, when R5 is sending this update to the R8 with the ACE number 5, right? When R8 will send this update to the R7, how this update will be happen? It is going to prepare the own ACE number. So for 5 and 8, sorry, not 5 and 8, 8 and 5. When R7, R8, sorry, R7 will send this update to the R6, it will send like this. It is going to prepare the own ACE number 7, 8, 5. And when R6 will send this update to the R5, the update will look like this 5.0.0.0. ACE number will be 6, 7, 8, 5 because it is going to prepare the own ACE number. So when R5 will receive this information on this particular interface, this update packet what R5 is going to do over there? He said that, hey, is number 5 that belongs to me. So I have generated this packet and you're sending it back to me as well as loop is happening. Let me discard this update just because of the ACE path information. So now if you see the debug message over there on R5 router, if you see, I'm receiving a one update from the 58.8, not this one. See this one. So 56.6, who is the 56.6? This guy. So R6 is sending the update to the R5, right? And what we are doing? Deny just because of the we have contained the own AS path information. We are just going to contain the own AS path just because of the this guy. We are going to just drop this packet on this particular interface. This is how we are going to prevent the loop in eBGP, guys, based on the ACE path information. So every router, if you just go back to the router number 8 as well as right now, and if you just verify show IP BGP, what happened? Can you see we are getting this update 5.0.0.0 from 58.5, that is this guy. And how do I get this information? I'm getting this information through the ACE path 5. That is this guy. And this route is my valid and best. So this star is just going to represent that valid. And this greater, I think so this is greater than. I'm a little confused with this stuff. This is going to represent it's a best. So if the route is valid and best, this route will be installed in your routing table. If the route is valid and best, this route will be installed in your routing table. If the route is just a valid, if the route is just a valid, this sign is going to represent a valid, and this sign is going to represent it's a best. If the route is valid and best, this information will be installed in the routing table. If the route is just a valid, this information only pertain in your BGP table. So right now, if you see this route is just a valid, and why this route is valid, I'll let you know. Don't worry about that. Okay, we're going to discuss each and everything very detail. So just giving the overview. So this route is just a valid. So this route will be never available in your routing table. Can you see which next hop is given over there? The next hop is given 58.5. That is this guy. This is the valid and best, right? But this is not a valid and if the route is not a best, if the route is not a best, it's just a valid, it only present in your BGP table, not in the routing table. So this is how we can prevent the loop, guys, in the eBGP. Whereas in iBGP, what happened? As I told you that in iBGP, we are going to use the in iBGP, we are going to use the split horizon rule. And what iBGP split horizon rule say that? Take example of this network, right? R1, R2, R3. Right? And I'm not interested in this one. So let's remove this guy. Also remove this. Also remove this. He's on the display mic. Now, if you see right now this topology, we have a router number 1, router number 2, and router number 4, right? So all this router number 1, 2, and 4, this guys belong to the ACE number 1, 2, 3. We can say that this guy is running with the iBGP between R1 and R2, and R2 and R4 we are going to run with the iBGP. Whereas if you see between R2 and R3, we are going to run with the eBGP. Why? Because this guy is the ACE number 1, 2, 3, and this guy is the ACE number 4. Between two different ACE number, we are going to run the eBGP over there. Now try to understand iBGP split horizon rule. What iBGP split horizon rule say that? Now to understand the IBGP split Trojan rule, you just need to understand this guy over there. So this guy is present on R2. What this guy is saying? This guy is saying that, hey, whenever I'm receiving the update from IBGP neighbor, listen to me. This guy is saying that, hey, whenever I'm receiving the update from IBGP neighbor, so the R1 and R2 is my IBGP neighbor, right? So whenever R1, sorry, whenever the R2 will receive the update from IBGP neighbor, this update 1.0.0.0.0, I will never share, I will never share the same update to another IBGP neighbor. But at the same time, I can share that information to the eBGP neighbor. This is the IBGP split Trojan shader. And by default, this rule is enabled. And this is how we are going to prevent the loop in the IBGP. Now the question is that why R2 is not sharing this information to the R4? Because in eBGP, whenever you are sending the update packet, in this update packet, what happened? We are going to put the NRI information, right? Network layer reachability information. With the same time, what happened? We are going to put the ACE path information like a 1, 2, 3. This is the eBGP update. Whereas if I'm going to talk about the IBGP update, in IBGP update, how the information will be there? You just have a 1.0.0.0.0/8. That's it. ACE path will be not present. So if the ACE path is not present, how can I prevent the loop? If the ACE path, when R1 is sending the update to the R2, is only sending the /8 information, 1.0.0/8 information. He's not going to put the ACE path information. And if the ACE path information is not there, how we can prevent the loop? So that's why what happened, R2 will never share this information to the R4. So what IBGP split will say that whenever the router number 2, or we can say that whenever the IBGP router, I'll just write on over there. Whenever IBGP router receive update from IBGP neighbor, it will never share the same update to another IBGP neighbor, but it can share, the same update to eBGP neighbor. This is the rule is saying that. So right, the rule is simple, right? So if you see the rule, so R2 is my R2 is what? R2 is my IBGP neighbor, right? So R2 is saying that, hey, whenever I'm receiving the update from the IBGP neighbor, I will never share the same update to the another IBGP neighbor, but I can share the same update to the eBGP neighbor. And by default, this rule is enabled, right? So if you just have a look over there, guys, on our router number 1, router number 2, and router number 4, and router number 3. And also show you the difference between the cap update packet of the eBGP and IBGP. So let's capture this link. Okay. And I'll do one thing on router number 5. I'm going to say the interface loopback number 1, shut down. Wait for some time. At the same time, I see that no shutdown. You will send the update message. Keep alive is moving. We must add information. Yep. You see the BGP information, we have a path attributes. So we have a ACE path information with the network layer security information. With the NRI, we have a ACE path information. This is my eBGP update packet. This is my eBGP update packet. Whereas, let's do one thing. I'm going to enable, first of all, I'll show you the pre-configuration of the router. So this is my router number one. So if you see the router number pre-configuration, show IP interface brief, exclude unassign. We have a source on section BGP. So all good. So let me do one thing. I'll say router number 1, 2, 3, no network 100. Just disable right now. I'm not going to do that. So we just have a single out. So no, we don't have energy. Okay. So router number 2, if you see, show IP interface brief, show run section BGP. So all we have a correct IP addressing over there, right? And the BGP is configured as well as. Go back to the router number 3 now. The router number 3, that is this guy. It should be 23.3 and they are running with the ACE number 4. Okay, they don't have IP addresses, so let's configure it. Router BGP number 4, and I say the BGP router ID, let's make it router ID 40404. That's a 32-bit number. And we need to make a 23.2, remote age will be 123. Let's see this configuration. Now we have a router number 4 as well as. If you see on router number 4, show IP interface brief, we all have IP addressing config 24.4, right? And so run section BGP, we all have a BGP configuration over there. All good. Now I'm going to enable the debug over there, debug IP BGP update. On R2 as well as I'm going to enable the debug IP BGP update. Okay, something is misconfigured. That's my notification message coming, right? It's 0 1/0. It should be a 23.2, but it's going to be 24.4. So, oh, come on. Oh, mistake is mine. Submit. So something is misconfiguration. I need to change this. Neighbor should be 23.3. The remote age should be 4. And neighbor 24.4. The remote age will be 1 to 3. That's correct configuration. So just wait for some time. So BGP is a little bit slow routing protocol, guys. So you need to wait for some time. Meanwhile, I can enable my debug over there and also on our router number 1. And router number 3 we have done. I think so. No. All good. So I'll capture this link as well as this link I'm going to capture. Okay. And this link I'm going to capture. I'll show you the each and every packet flow over there. And this link I'm going to capture. All good. So now if you have a look over there, what happened on a router number 1, I'm going to advertise this route, right? And by default, split horizontal is enabled, right? IBGP split horizontal. Router BGP number 1 to 3. And I said a network 100.0.0. Guess what happened, guys? R1 will send this update to the R2. R2 will accept this update, but R2 will never share this update to the R3 just because of the IBGP split horizontal. Whenever the router number 2 will receive the update from IBGP neighbor, it will never share the same update to the another IBGP, but it can send the update to the EBGP. So if you see network 100.0.0, sending the update to the 12.2, right? R1 is in the update to the 12.2. R2 will accept this update, receive update from the 12.1. And what we are doing over there, we are just sending the update to the 23.3. That is EBGP, right? 1 minute, something I have issues here in the wrong issue. Why? The confusion I did on this. Oh, a mistake. Router BGP 1 to 3, enable. So let's do one thing. Let me advertise this guy again. Then I'll show you this thing. Remove this guy some debug from R2 as well as remove something from R3 as well as from R4 as well as. So let me form the BGP neighborship first of all to show IP BGP summary. Active state is there. Just wait for some time. Then I'll show the same debugging. All good. So now R1 network 100.0.0. R1 will send the update to the R2. R2 will receive this update, right? 100. And what R2 will do in this case? R2 will just send this update to the R3, right? That's the eBGP. But R2 will never send this update to the R4. So if you see, there's no update is happening on R4 24.4. I'm receiving the update from the 12.1. R2 is receiving the update from the 12.1. It only sending the update to the 23.3 because of the eBGP. But on R4, can you see my debug is happening, right? I do show debugging, but no update is coming. Do show IP BGP. I don't have a information on the 1 or 2. On a R4, we don't have information on 1 or 2 just because of the IBGP split origin rule. So it means that whatever the user that are sitting behind this guy and whatever the user that are sitting behind it, they can communicate to each other, but the communication will not happen from here to here. The communication will not happen between this guy, the PC number 1 to the PC number 3, because they are not exchanging the update just because of the IBGP split origin rule. But if you see, R2 will send this update to the R3 because R3 belongs to the eBGP. So if you see just now as well as one output over there. So when R1 is sending the update to the R2, do we have any AS path information over there? No, we don't have AS path information. But when because IBGP does not add the AS path information in the update packet. IBGP does not add the AS path information in the update packet. But when R2 is sending the update to the R3, that's the eBGP. R3 will receive the AS path information. That is going to R2 will add the own AS path information on there. Prepare the own AS. So even if you check on a router number 2, what we have over there. So IBGP, we don't have a AS path information. But if you go back to the router number 3, we have a AS path information over there. And if you just verify the update packet, the BGP, I'm interested, that's coming by the 12 R1 is sending the update packet to the R2, right? So it should be 12.1. So I can go for anyone open this guy. We have that. If you see, this is my IBGP, and in the IBGP, what happened? The AS path is totally empty. That's this information that I want to show you. So if you see the eBGP, and this is the IBGP. Right? We have a AS path. So IBGP does not contain the AS path information. Never. Whenever the IBGP router will exchange the update, it will never contain the AS path information. But when IBGP is going to leave when IBGP router leaves the update packet to the different AS number, or we can see that when IBGP router is going to exchange the update to the different AS number from here to here, different AS number, it will add the AS path information. So if you see the link between R2 and R3, And if you just open the BGP and open the update, you will have a ACE path information. Not this one. Can you see? So same information 100.0.0 ACE path. So when IBGP router leaves the own ACE information, it will add the ACE path over there. So it is something like the update is happening. R1 send the update to the R2 100.0.0, no ACE path information. R2 will never share this information to the R4 just because of the IBGP split routing rule. But when R2 will send this update to the R3, it will put the 100.0.0.0 with the ACE path will be 123. This is how we are going to prevent the loop in IBGP, guys. So anyone has a questions till this point? No? Okay, thanks.